away from the linear stuff, okay, which is good. So the stuff we do the next couple weeks, it's definitely different. I think you'll like it. It's not that challenging, and then it will crank up a little bit right before we go off on break. Your tests were pretty good. I get asked all the time, is it one big test or two separate ones? The response is, it doesn't matter. Okay, it's worth the same amount to your grade. So if you would rather view it as one big test, makes you feel better, cool. If you'd rather view it as two separate ones, also cool. It does not mathematically make a difference. Okay, I'll get those back to you. Okay, I do have a couple people need to finish up part 2. That'll happen over the next few days. But otherwise, hopefully you saw your grade. You can move on. If you got the extra point for the buzzer game, I did not add that on yet. So at some point that will get added on to part 1. Okay. Cool. All right. You will need a graphing calculator in this unit every single day. You will also need one at home. So if you've been faking your way without one, that's probably going to be an issue. There's certain things we do in here that without it, it's not going to go over particularly well. Okay, but every day when you walk in, I'm not going to stop the class and be like, all right, get a graphing calculator. You walk in, okay, Isaac, stop. What are you doing? Don't lose your calculator privileges, okay? You walk in, get your homework out per usual. I want the graphing calculator. It'll be every day until I tell you differently, okay? Now that said, the last time this group used my calculators, this is what they look like at the end. I will take them away from you, okay, because this is unacceptable. In general, I don't like the way you leave a lot of my stuff. You are better than period 6, but that's not a high bar. It's not a high bar. Okay, they should not look like this. Screaming for help out of the case, like no good. So when my calculators go back, and I will take them away from everybody, I just don't care. This is how it should look at the end. The case on, okay, the round side down. They usually have 30, 6 slots. You do the math on that. The more you play with my calculators, the more likely they are to fall. The more likely you are to lose the privileges. They should be flat on the desk. You're always welcome to use your own graphing calculator, but they're essentials to the rest of the unit. So my advice, take better care of mine. Okay? Now, if you notice the early slide, okay, this is optional, but it helps me. One thing, if you happen to have any pictures of your pets with money, please email them to me over the next week or so, and I will include them in the slides because it relates to what we're doing. So here's some examples I've received in the past. Things like this. Or this, which obviously was adjusted, but still, you get the idea. This person showed effort. It wasn't real, but I took it still. This is real. And good, okay? So if you're able to capture moments like this and email it to me, please do. I will include them in the slides. They relate to what we're doing. If you can't, that's fine. I don't really care. Okay, we go forward from there. All right, so let's open to the first thing. Okay, first thing in there, 1.1. Let's go. Come on, find it. Okay, we are going to start looking at, I like this topic. It's pretty light today. We are going to start looking at exponential growth, okay? I am curious, how many of you, okay, don't lie to me, nobody's impressed. How many of you have heard of this word just on its own? Forget math for a moment. How many of you have heard the word exponential before? Probably pretty common, okay. At the very least, you've heard of exponents. It's related. Okay, now has anybody actually heard of something growing exponentially? I can tell you did. You might have been too young to remember, but the very first time this guy came into our lives, the concern was that it was growing exponentially. Okay, now you might not even remember. I don't even know. You were 5 years old, 6 years old at this point, whatever. Same. You barely knew what was going on. Okay, the concern was it was growing exponentially, and that's why we kind of had certain things we need to get fixed with. Okay, how about a reader? Somebody to read this other than me. August, thank you.
In this investigation, you will explore exponential growth. You will cut paper in half over and over to experience exponential growth.
We won't do that, but we'll talk about it. Keep going.
You will read a story about the land of Montreal.
We will do that.
The story shows how exponential growth can be used. Finally, you explore exponential growth patterns and compare them to linear growth patterns with tables, graphs, and equations.
Little TGE. Table, graph, equation. It's not as bad as pre-algebra, but we will compare it to linear stuff, even though we're moving on from linear stuff because it's what you know the most about. Okay? How about another reader? Somebody else. This is great. It's a big moment here. Yes, Anna.
Jen is Secretary of the Student Government Association.
Okay, let's stop it there. Chen is a legend in this classroom. If you have to ask why, you'll never know. But this is your first experience with Chen. So let's all take a moment and just breathe this in. Okay, Chen, go ahead.
He's making ballots or ballots.
Ballots. No, you were right, ballots.
A meeting. Chen starts by cutting a sheet of paper in half. Then he stacks the 2 pieces and cuts them in half again. With 4 pieces now, he stacks them and cuts them in half. By repeating this process, he makes smaller and smaller paper ballots.
Have any of you actually done this before where you want to make 2, so you like fold it, and then you're going to cut it, and the edges don't really line up, and then you're annoyed that it's not what it should be? Okay, but that actually is the process and what he does. Does anybody know how many times you can actually fold a piece of paper?
7, 8, 6 or 7.
I've seen it broken. You can finish 7.
Who said 7?
Maybe. Wait, can I fold it without folding
Let's see it.
That's the one. Yeah, that's the.
That's got to be a standard piece of paper, 8.5 by 11. Count them out. Oh, you didn't? Oh, that's 1. A little quicker. A little quicker. Okay, we're doing this on purpose. I do this every year, but I'm giving you this moment. Alright, the moment that you've all been waiting for.
6. Don't even think about it. 7 minutes.
No, that's 7. That's 7, right?
No, 8. That's 7.
You can't. That's 7. Hold on, I'm almost. Okay. There actually is debate about whether or not this predates your ridiculous little trends. There's always debate about whether or not the 7th one is actually a fold, but you definitely can't go past that. So this is a good job. Okay, high quality. Okay, cool. But a lot of you, if you haven't done this, you've thought about it. If you need to do double of something, you'll fold it and then cut it, and then instead of getting 1, you'll get 2. Yada yada yada. That's the premise of the problem. Okay. Let me tell you how this activity is going to work. You're not going to get very much from me at the beginning. You're going to answer as many questions as you can with little help from me. After each cut, Chen counts the ballots and records the results in a table. It looks like this. You can ignore the small table. Go to the next page. There's a big table. Don't bother with the small table. Okay? Listen carefully. I'm going to give you all the directions and then let you go. But you got to listen, because then you're going to ask me questions. I'm going to say I covered that already. You're going to fill in the table. You should definitely talk about the table with other people. If the table's wrong, everything's wrong. After you fill in the table, you're going to look for a pattern or an observation, just like 1 or 2. Nothing too crazy. Okay? After that, I can already tell some of you aren't listening, and then you're going to really be lost later. You're going to graph the data. You're going to write an equation. I'm going to tell the whole group, you will not all get the equation without some help. Some of you will get it. Some of you won't. I will not help you find the equation. I want you to experiment. You have the graphing calculator. Okay? Do not cheat. Do not look at my completed class notes. That's cheating. Okay? Through a little experimentation, I hope you get the equation. Here's the good news. Here's what you got to listen for. If you can't get the equation, you can always come back to it. You can answer most of these questions without one. How does the growth pattern show up in the graph? You can answer that even without the equation. Is this relationship linear? You can do that without the equation. Okay, oh, my favorite slide of the year. This. Yeah. See, it's like Ben and Jerry's, but instead of Ben and Jerry's, Chen and Jerry's. I think some of you get, you know what? Some of you don't get it.
No, I
Let's
get
break.
it. I like
I don't know, some of you do, some of you don't. Let's break it down just a little bit more. So it's like Ben and Jerry's, but instead, Chen and Jerry's. Oh! Okay. Wait, I'm almost done. Because some of you don't see this coming. You can still answer this question even if you don't have the equation, although it would help. And you can still answer this question even if you don't. So Don't obsess over the equation. Do all the parts. If you get it, that's great. If you don't, you should do other things and come back to it. Okay, I would encourage you to work together. Starts by filling in the table. Go ahead. Big table. We're just going to leave this up.
I wonder where
That's why the one group costume was Chen and Sari, because her name was Sari, so that's why. If you wonder why that group won, now you get it. Chen and Sari's. What? But now you know. I'm not convinced enough of you get this joke. We'll go over it later.
It's good. Who's bad?
I like the previous Very wrong. He's got up by 2. He's
Yes.
What? Y equals 2x. I know, but you're built like it.
What? Oh, yeah. Yeah, there it is. I gave them to the home base that we were partners with.
Built like one month.
We're very rambunctious today. Can I show the table? Because, by the way, not all of you have it. A lot of you do, but can I show it? Because if your table's wrong, everything's wrong. Ready, set, boom. There it is. If you need to fix it, if you need to fix it, you should start there. It's got to be this. It doubles. Every time he folds the paper, it doubles. That's why it's going up times 2. Now, I will not validate any equations. If you get an equation, what's the best way to check it? Put it, you're not listening, put it in y equals. If it matches that table, it's right. If it doesn't, it's wrong. That's why I don't validate any equations. You validate your own. As you were.
I found the equation.
It's like when you make 0, you need to do a
Please, speed, I need this.
What even is that?
It's basically yourself, speed, and like a few other people in context.
Judith broke it.
In a game. And basically, whoever wins this, he just goes to
Why?
I show speed.
I told you, some of you would. Yeah.
It's hosting the
I did, like, I was validating it. I was just over right
His mom is
Mama, we're talking to
Wait, what? Oh yeah, please read this. I found that on my instance that and also Colin, do you remember?
She wanted to be very toasty. I knew every grade one.
well, all my we should do this one called ALPM. It's a good one. We're going to tell me, please, Ash, I need this.
Please focus on the graph. I'm going to get a little bit more nitpicky with it. There's a couple things you got to make sure you really have. And remember, you can graph the data even if you don't have the equation. Some of you do have it, but you can still make the graph no matter what.
Yes.
Are you still playing Pacific or still?
No.
I kind of quit. See, I'm like,
You're scared?
you're delusional.
You're scared?
Come on, how do I draw the graph?
64.
Did you draw your graph?
256. 1024.
That's like catch.
Wait, no, it's not
Oh, I understand.
How does, what's the name?
Gary's.
Without saying it out loud, how many of you are confident you have the equation? Like you checked it in the table? Pretty good. Pretty good. It had to be checked in the table, otherwise we wouldn't know for sure.
They already announced.
You got it right.
I know. We're going to talk about it.
He's actually
We're actually in pretty good shape. Probably about 5 more minutes. We can start going through a couple things.
Oh yeah, and that's just what that
We don't know what that is. I got plenty of this stuff to do here. Then there's still scientific notation stuff. Come on. Some of your graphs are lacking.
We need more.
There, that's much better.
Let's talk graph. Well, that's what you need. Okay. So, let's go back to the table. You all told me, at least from what I can tell, you all told me that this table was fun. If you didn't do this, please write down next to the table this. I need the observation. A lot of you skipped it. As the number of cuts increases by 1, the number of ballots double, multiplied by 2. We're back into like some of the connected math, like ACE type stuff, just a little bit. You have to answer these questions carefully. You know how to do this stuff. Okay, get a little break with it. Okay, but we're back into some of it. Okay, that's the pattern I would describe. As the number of cuts increases by 1, the number of ballots doubles. Let's talk about your graphs. A lot of them are lacking. Now, some of them are wrong. Most of them are right. But some of them are definitely lacking a few things. 1, labels. My goodness. How some of you lost track. You should have number of cuts on the X. Some of you are already putting that in. Number of ballots on the Y. Your points. Well, usually somebody finishes my thought. Your points. Well, okay, there's that. They should not be connected. Ballots and cuts. I told you you had a break from that for 1 unit. We're into a new unit. I think you should have realized that. I gave you new stuff. Okay. There are no partial cuts. There are no partial ballots. There's only whole ballots. Okay. So other than that, now some of you didn't graph all 10. Some of you only graphed like 5 of them. I mean that's okay, but I'd rather you graph them all. I want to talk about this graph for a moment. What shape is this? It's curve. It's a curve. Calling it a curve is fine. I want to look at it because if you did this the right way, which some of you did, some of you did not, it kind of looks like they're all like 0 at the beginning. You know what I mean? And then, boom. That is exponential growth in a nutshell. You're going to see it all unit. The idea behind exponential growth is it starts small. Let's go back here. It starts small. And a lot of you know because you're on to further questions, the numbers get very big very quickly. That's exponential growth. Okay, the graph matches that. Okay, the graph starts out really low and slow, and then once it gets going, it gets going. Okay, so a lot of you were missing your labels. Your points should not be connected. It is a curve. Okay, question. Oh, you'll see that at some point. Don't worry. Not next week, I think the week after. It's coming. Okay, the last thing I want to do, because no one's done yet from what I saw. Okay, there's a couple things to do still, but you have the graph. I do want to make sure everybody has the equation before we go forward, so somebody want to raise their hand and tell us. Okay, Alex, what is the equation? Okay, I think a lot of you have it, but just in case, let's jot down y equals 2 to the x. And I told you, I don't validate equations. Why would you ask if an equation's right when you can go to y equals, enter 2, how do you get it to the power of x? You should know this. The caret. And then go to the table, and it's right. Never ask when you can check it yourself. That's just like lacking confidence, okay? That's the table, that's 100% right, okay? So what do you need to finish now? You have a couple questions left. You have these, you have this, you have this, and then yes, there are notes on scientific notation. I do want you to start reading them, we will talk about it. A number of you have actually had this popping up on your stars. Today's the day, okay? So you need to finish these questions, those couple, and I do want you to start looking at scientific notation, okay? And answer the questions that go with it. Go ahead. Pick up from there.
Shall I go back into clip?
Okay, let's do more.
Tommy, I have a question.
What? For what? I know. We're going to talk about all that stuff. It's time. Read all that stuff below and then maybe see what you think of it. We're going to talk about it
Because the four.
Wait, Calvin.
We skip all these questions. Come on. We'll talk about all the stuff, the E, all that jazz. We'll talk about all of it. You know, you know.
Do you want us to keep going?
Yeah, good questions. Go with us on next page. Yeah, maybe we're going to talk about it together, but you can start with that.
No, it's not common. It's no, it's not. It's like 1.09 something. It's not
I'm going to say another 2 or 3 minutes, and then wherever you are, we're going to come together. You should at least be working through these questions at that point.
No, that's the 11. I know.
2 minutes. Just to be as far as you can. You might not be done with everything, but that's all right.
Yeah, it's
2 minutes, we'll start checking.
like 3 zeros at that. Yes, it is. I can do it on my calculator. I got this.
The person is 13.
Is that 7?
This one is
Yeah, it's correct.
It's so safe.
I didn't type it. Oh, that was clever. 7. That one's clever.
Last minute. We have some stuff we need to clean up, don't worry.
Like just, you know how you thought that was, how you didn't
I didn't know what you were saying. Or when you were talking about.
Alright, pencils down, let's go. Couple things I'm gonna need you to add in, a couple things that we will clarify. Okay, so we did all that other stuff. Let's talk about questions 2 and 3. We will talk about the scientific notation stuff, but we need to clean these up first. Let's actually go with number 3. I told you, no matter what you had on your own, you could answer number 3. Okay, Isaac, put the homework away. I'll rip it up and make you start fresh later. I don't care. We're not doing that. Put it away, all the way. Okay. I told you you could answer number 3 even if you didn't have the equation, as long as you had the graph. What did we say? Is it linear? No, but I need you to capture all of this. I need you to capture all of this. No, there are not constant changes in the dependent variable. You don't have to erase what you have. You can add to it. Or constant changes in the independent variable. I'd be stunned if everybody wasn't writing that. I've never had a student write that word for word. Maybe you did, but it'd be unlikely. I also want you to say the graph is not a line. And the equation does not fit the form y equals mx plus b. Those are 3 reasons why it is not linear. You probably didn't write down all 3. I didn't expect you to write down all 3, but we're doing it now. Because if it was linear, wouldn't it fit the form y equals mx plus b?
Yes.
If it was linear, wouldn't the graph be a line?
Yes.
If it was linear, every time the independent variable changes by a set amount, the dependent variable changes by a lot. Yes, it's overkill, but for all those reasons, it's not linear. Most people probably just wrote down no, or gave me one thing. I want to talk about number 2. How does the growth pattern show up in the graph and in the equation? I think the equation's obvious. Anybody want to tell me, how does the pattern of change show up in that? Maybe it's not obvious. What is the pattern? Every time x goes up by 1, y.
What goes up by y?
No, it's not y goes up by y. Y. Oh, we wrote it down. Every time x goes up by 1, it doubles, multiplies by 2. I thought it was obvious, maybe not. How does the double or multiply by 2 show up in the equation? You can't just say the 2 though. What's it called? You should know this.
It's the coefficient.
No, x is the exponent. No one knows what the 2 is called.
It's the thing before the exponent.
It's the base. You should know that. Okay, the base. Now, I think the graph is less obvious. Okay? Again, we're writing this word for word. Every once in a while, I need you to have something exact. These are those moments. The graph is an increasing curve with increasing vertical changes. That's hard to describe. I'll show you what I mean by that in a moment. The equation has a 2 as the base. It's not the coefficient. You can't just say the 2. 2 is the base. It's not the exponent. What's the exponent? X. X is the exponent. Okay. Sounds like all of you forgot it was called the base. That's okay. Relax. I want to talk about this. This is hard to describe. That's why I'm asking you to write it down, because I think it's hard to describe to somebody else. So if I go back to my lovely graph, which, whatever. I'm going to look at the vertical changes. Now that's not going to help me at the beginning because they look like nothing. Watch what happens when I start measuring not the horizontal change, the vertical change. I'm going to eyeball it here. Is that the vertical change? Yeah, eyeball it. Okay, if I do these guys. Yeah. Okay, well, let's do 2 more. Okay, let's do this vertical change. Yeah, something like that. Okay, and we do 1 more. Well, if I could take all these things and legitimately compare them, if you try hard enough, I know it looks like a cell phone signal, so to speak.
Oh, you can't see that.
I know, it's close enough. You can actually see the double. Right there. That's hard to get into words. That's why I gave it to you. So the graph shows increasing double vertical changes. Okay? Cool. Now let's get to these because I need to tell you what you can do and what you can't do. Okay? Suppose Chen could make 20 cuts. How many ballots would he have? How many ballots would he have? He could make 40 cuts. This is where having the equation is nice. You know what you would have to do if you didn't have the equation? You'd have to do this. Which, by the way, well, you could. Believe you could. We'll be waiting there forever. Okay? That's if you didn't have the equation, you could get it. But I want to talk about what you did get and what it all means, and that feeds into the bottom. Okay, so the first one should be 2 to the 20, should be that. So your first answer, how many of you have that guy written down? Okay, good. Should be everybody. Now, okay, don't be a savage any more than everybody in here is already slightly savage-like. Put commas in. And that's not just for me. You're going to get them wrong if you don't put commas in. Okay, so what is that exactly? Go ahead, say it. 48,576. That is your answer. No debate. Then you do 2 to the 40, which is your next one. And you end up with that. And I want to talk about this now because you need to know what's allowed and what's not allowed. Okay? Isn't that what the calculator spits out? Okay. You are not allowed as a human to write E and say E. You are not allowed. That is the calculator's option. Okay? Now, if you don't know what that is, we're going to look at it now. Okay? But that is what the calculator spits out. Okay? This one I can do quickly. Isn't it 9 cuts? It can't be 8 because 8's not enough. Is it 9? Yeah, 8's not enough. 9 is some with extra. Okay? Let's go back to this. This is scientific notation, but it's only calculator speak. Okay, you need to have it correct. So let's start talking about scientific notation now. I've been told this pops up on your star quite a bit, this kind of stuff, does it? Yeah. Well, guess what? Now you know it if it ever does pop up again. Scientific notation is a way of writing very large or actually very small numbers. Even the calculator has limits. It can't display certain numbers that are too big or too small, so it's a shorthand way of doing it. Okay, it's all written in powers of 10. Scientific notation, by definition, is a number that has the form a times 10 to the n, where these qualifications have to happen. So let's look at a. What does a have to be? You know how to read this. It has to be greater than or equal to 1. So it can't be 10. Okay, so let's look at an example. 5.59 times 10 to the 6. Okay, that's already written in scientific notation. Expand it out, 10 to the 6. You know what multiplying by 10 does to the decimal. You've known for a while. What does it do? Right one spot. So if we expand this out, 1, 2 gets us to the end. We have to keep going. 1, 2, 3, 4 more. We fill in the zeros. So this, written in scientific notation, looks like that. Okay? If I go back now, the calculator can't write out the times 10. So I want everybody, I don't think you have this, but you might, for this answer, for 2 to the 40, I want you to rewrite it the human way, which is 1.099511628. Go ahead. Yeah.
Times 10 to the power.
Good. Times 10, and we're not done with it, 10 to the power of 12. That's how you write it, human being. You do not write E, you don't say E. That is specifically for the calculator. Okay? Now that's not the answer. That's just it shorthand written. Based on what we just learned, to get the real full-blown answer, we're going to take this decimal point and move it where? 12, not back. 12 to the right. Watch this. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got to keep going. 10, 11, 12. They're like little egg cartons. Can you stop doing that? I have to fill them in with zeros. So the answer, which you should be writing now, is 10995111628 with 3 zeros tacked on. Comma, comma, comma. What, 1099? Yeah, it should be here. Well, we're going to count. We're going to count it out now. We're going to count it out now. So boom, 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 boom. Hundreds, thousands, millions. 1,099,511,628,000. And, no. And this isn't even right. It's rounded. There's no way these are actually zeros, which we will get to. Okay? Leslie, question. Yeah, I don't want to go into the table right now because the table rounds stuff off, okay? But that's how scientific notation is read. But it works in the opposite direction too. Small numbers. 0.0000318. Let's go all the way back to like grade school here. What's the first one? What place is that called? Tenths. Tenths. Hundredths. Yeah, there is that. So tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. So this is microscopically small. 318 10 millionths. Very small. You can write it in scientific notation, but based on what we learned, there's only one place I can put the decimal point. Why can't I put it there? Too small. Can't put it there. Too big, right there. So 3.18, 10 to the negative 5 means I move 5 spots, not to the right. To the left, okay? That's how scientific notation works, okay? So I'm going to show you one or two of these, and then you need to get them finished up. But if I want to write it in scientific notation, this guy, the first thing I need to do is put the decimal in the right spot. Who can tell me the only place where the decimal point can go to fit the right definition of scientific notation? Alex. It has to go after 1. If I put it before 1, it's too small. If I put it anywhere after, it's entirely too big, okay? So you put the decimal point there, and then how many spots would we have to move to get it to the end? No. 1, 2, 3. At least he's trying, but it's actually 6 spots. Count it, right? 1, 2, 3, 4, 5, 6. How do we write this? 1.34 times, come on, 10 to the power of 6. Okay? That's writing it in scientific notation. This next one already is in scientific notation, so we have to convert it. What does 6.88 times 10 to the negative 2 mean? We're going to take the decimal point, move it 2 to the left. So what is this guy written out? 0.0, come on. Okay. So that's how the rest of them are done. I do want you to finish them, okay? Either write them in scientific notation, or if it already is expanded out, check them with each other. We'll put them up on the board and we'll check them. You can check them with the calculator, but you shouldn't need to. You're either writing it in scientific notation, or if it already is, you're converting it back to standard form or regular answer. There's your next one, 7.75. It's got to go there. It can't go anywhere else. Times 10 to the negative 4. How do you do that one? Very good. Once you get the hang of it, it's really not that bad. This one, I've got 7.2. 3. There's your next one, the top row. I like to fill them in like egg cartons. I don't know. When I do that, put the eggs in. Yeah, you don't have to do that, but you gotta get it right. That's what I would do. You can't just type it into the calculator because sometimes you don't get that. You don't get the graphing calculator to handle the digits. I feel like some of you want your STAR exam back now. I bet you'll see it again. Now you know how to read it. That's all. It's just how you read it. It's just powers of 10. Sounds like most of you are good.
With the numbers here, we say that.
Now, scientific notation, the reason we talk about it today is we're going to use it the entire unit. The entire unit, numbers are going to become very, very large or very, very small. Okay? You all good?
I'm kind of stuck on this one.
Okay. Well, you got a couple minutes to work on it, man. That's all I can say. So do the best you can with it. We're going to use it the entire unit. Numbers are going to get very, very large or very, very small. You need to know how to read it. So if the E pops up on the calculator, no one walks up to me and says, what does the E mean? The E means the power of 10, but you don't write that. You write times the power of 10. Now I want to talk briefly about exactness. Okay, so let's go to this 2 to the 40. Okay, so go to your calculator. There's our home screen. The home screen can only handle, I don't know if anybody noticed, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. Okay? We don't need that right now. Okay? If you look in other spots, you can find different amounts. Okay, so you should have y equals 2 to the x in there, like you should. It's been in there all class. If not, enter y equals 2 to the power of x. Okay, let's actually skip to 40. So let's jump to 40. And at first glance, it looks like everything's rounded. 1.1 e to the 12. But actually, if you just do this, if you just go over to the right one spot, that's actually more exact than the home screen. The home screen can only handle 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 digits. There's more. So this is actually more exact. And that goes back to something I was saying a few minutes ago. There's no way each of these is a 0 at the end. They're all rounded off. If you don't believe me, look at your first table we started class with. Guess what it never ends in? The calculator just gives up. At that point, it decides, I can't handle any more digits. We're going to round all these off. Well, that's hundreds of ballots, hundreds of numbers. Okay, so even the calculator at some point runs out. But, okay, if you look in different spots, if you look in the home screen, you get 1. If you go to the table, if you go right over here, you can actually get more digits. If you keep going down, now at some point the calculator gives up and it's like, I need scientific notation. And if you do something preposterous, like if you jump to like 300, okay, at some point it's there. But if I jump to something real crazy,
Huh.
I wonder.
well,
Yeah.
it's not that the number is an error. Most of you don't read error messages when you get them. Most of you don't. You get an error message and you say the calculator is broken or something's wrong. If you read the message, it tells you what the error is. What is the error called? Overflow. What does overflow mean?
Too much.
Too many. Too many digits, too high of a calculation. We've run out of space. Can't calculate it, okay? None of those are accurate. There is no error, okay? None of that. That just means the number's too big even for that calculator, okay? Cool. This is super crucial. You can't let period 6 have any of that. Not the equation or nothing. They don't deserve it, just like you wouldn't deserve it. So clear it out. Second plus 712 every single day. Second plus 712. Turn it off. You should turn the calculator off. Put the lid on. Put them back. And it needs to look like this. Don't lose your calculator privileges. Come on. What? Yes, they gave me an honor certificate. Max, let's go. I got half a minute. Max. Let's go get up.